all that being said, without further ado, thank you for joining us. Eitan is a postdoctoral researcher here at Northwestern. He studies the relationship between sleep and memory. So the floor is yours, Eitan. Thank you for being here.
Okay, thank you very much. Can you all hear me okay?
Yes.
Yeah, great. I am going to share my slides. And what I try to do here, because there's always the issue of the faces obscuring part of the image, then I put like a slot on the upper right part of the screen, and you can just try and put my head right there, and there will be no information on any of the slides in that little box on the top right.
Eitan, just a quick note. I think we're seeing your presenter view and not the actual slideshow.
Thanks for letting me know. I'll fix that.
And also one last thing, if you want to ask a question, feel free to ask a question at any time. Otherwise, I would ask that you please mute yourself just so we can hear the full extent of what Eitan is saying without any interruptions. So if you want to ask something, feel free to go ahead to post it in the chat or ask in person, but otherwise, please try to mute yourself. Thank you.
Okay, so as I was saying, you're welcome to put my face on the box on the upper right, and that will not obscure any of the slides. Great, so let's dive in. So my name is Eitan. So, okay, we'll be going over, I'll talk a bit about me, then a bit about sleep. Then I'm gonna focus mostly on sleep and memory consolidation, and the question of whether we can affect sleep consolidation in some external way. And finally, I'm going to dedicate just a slide or two about sleep in older adults. So I am originally from Israel. That's where I completed my bachelor's in psychology, and also my master's and my PhD in neural computation. I started working as a postdoctoral fellow at Ken Paller's lab at Northwestern in 2016. And my study will focus on the mechanisms by which mechanism by which memories are strengthened and during sleep, and we'll talk a bit about that as well. So, second, sorry. Okay, so here I go. Okay, so let's talk a bit about sleep. So it seems like a silly question, but what really is sleep? How can we define sleep? We can probably say that sleep is the state we're in when we're not awake, but that's not a very good definition. And it seems as though this trivial question has really bothered and troubled many people, especially because some of the things that we might relate to sleep are not associated exclusively with sleep. So what is not sleep? So sleep is not a simple lack of consciousness. If you just pass out, that doesn't mean you're asleep. Sleep is also not being under anesthesia. So even though these kind of behaviors share a lot in common with sleep, we wouldn't say that someone who passed out or someone who went into surgery is asleep, even though they're not awake for sure, and they do have some of the features of sleep, but it's not exactly the same. And the same goes for someone in a coma. So they're not responsive, they're not awake, but they're not exactly asleep either. So sleep is basically characterized by a bunch of different features that have to all exist in parallel for it to be called sleep. First of all, it has to be a natural thing. So sleep is naturally occurring. It's periodic. It happens on some sort of cycle. In most living things, it happens during the 24-hour cycle. And then it involves some relaxation of muscles and less movement, and also some suspension or reduction of consciousness. So if we really want to use these criteria, then we can see that many animals sleep. For example, flies, as I've shown here on the bottom right, if you look at flies, they don't sleep like we do. They don't close their eyes, for example. That's not something that's necessary for sleep. But they do have a period of time that is periodic across days and in which they move less, they are less responsive to stimuli, and it does occur naturally. So we could say that's fly asleep, even though looking at a fly asleep and us asleep is probably very different in many, many ways. So the next question I want to try and ask after the question of what is sleep is why? Why are we tired? Why do we fall asleep at some point? And again, there's the trivial, I guess, answer, but it's not always the sufficient or not always all there is to this story. And the trivial question is that we do a bunch of stuff throughout the day. We kind of accumulate this sort of tiredness or a sleep drive over the day. We become more and more asleep, the more hours, more and more tired, the more hours we are awake. And at some point, it passes some point and then we go to sleep. During that sleep, that sort of thing goes away, and then another day starts, and again, it starts to accumulate up until we can't stand it anymore, and we go to sleep. And that seems like probably a pretty easy solution, but anyone who's ever had jet lag will know that that can't be everything. Everyone who's ever traveled, for example, even within the country, but especially overseas, will notice that sometimes they are very exhausted but can't fall asleep. That's not enough. There's something else going on here. And that something else is called the circadian cycle. And the idea here is that in our brains, we have some sort of monitor that tells us what time of day it is. This is based mostly on the light that we perceive, but there are some other factors as well. And this is a cycle that runs 24 hours or sometimes a bit more than 24 hours in most of us. And we have to sync that up with our tiredness to fall asleep. So these are two sort of processes that are happening in parallel. One is more in a cycle-like way, and the other really depends on your activities throughout the day or when you woke up or what you did. And we have to have this sort of gap, this sort of difference to be kind of large in us in order for us to fall asleep. So we have to be in the correct time in the cycle, and we have to be tired enough. If we don't get both of these, we probably are going to have trouble falling asleep. So that's the major aspect of why we fall asleep. So that's a bit about sleep, and now I'm going to focus mostly on sleep and memory consolidation. And before I dive into more recent findings and science about this, I have to say that this is not a new finding or a new phenomenon that has been described. In fact, 2,000 years ago, the Roman rhetorician Quintilian was probably the first, at least the first on record as saying that he noticed that there was some sort of something happening during sleep to our memories. So he is quoted as saying, "It is a curious fact of which the reason is not obvious, that the interval of a single night will greatly increase the strength of the memory. Whatever the cause, things which could not be recalled on the spot are easily coordinated the next day, and time itself, which is generally accounted one of the causes of forgetfulness, actually serves to strengthen the memory. So over time, we forget, all of us forget things. But during that time of sleep, it seems that memory might actually be enhanced and not only, and not deteriorate as we are, we usually happens during our waking hours." So this is 2,000 years ago, but surprisingly, this idea has gotten very little focus in research during those 2,000 years. And the first major to really concentrate on sleep's role in memory happened almost exactly 100 years ago. And we'll get to that in a second. So sleep improves memory, and then a bunch of other questions show up. Which memories are strengthened? Which part of sleep is important? Is it the dream sleep? Is it other parts of sleep? And how does it actually work? What really happens during this period of time in which we are asleep? We're going to touch on these topics in the next few minutes. So which memories? The first study, the one I mentioned, that really systematically analyzed how sleep and memory are connected, happened or was published in 1924. Back then, studies were a bit different. There were just 2 participants, and they were studied multiple times. And these 2 participants in this 1924 study learned a bunch of nonsense syllables. That is, they just learned a bunch of words that made not a lot of sense. And then they were tested about how many of those they recalled after different periods of time. It could be, so this is the x-axis we see here on the bottom. They were asked to recall these after an hour, after 2 hours, after 4 hours, or after 8 hours. And as you can probably guess, they got worse the longer the duration was. But the important thing and the new thing that happened in this study was that during that 1/2/4/8 hours, the participants either were awake or they went to sleep and then were awakened for questioning. So they were either awake for an hour or asleep for an hour. And the striking finding that you can see in this curve is that whereas people who were awake for this period of time, which we can see here in the empty circle and triangle, their memory deteriorated at a certain rate over time. The same participants, when they were asleep, actually deteriorated less. So it seems as though sleep at least conserves some of those memories for facts. In this case, it was facts or a recall of a certain word. Maybe fact is too strong of a word, but recall for something that is explicit and has been learned. Another form of memory that we know is strengthened, other than memory for facts, is memory motor learning. So motor learning is a term that encompasses the kind of thing that we usually don't talk about in regard with memory. Like riding a bike would be a motor learning related memory, or tying your shoes. So those are the kind of memories that we don't usually think about when we think about memory. But they are also improved by sleep. In this study that was done 18 years ago, people had to learn this finger tapping task. So they had 4 buttons on a keyboard, and if you look at this at my screen right now, they had to memorize a specific order, which was 1 4 2 3 1 4 2 3. If you do that a bunch of times with your fingers, you kind of get the hang of it. They didn't have to, it's kind of easy to just remember what the sequence is. The question is, how fast can you type it in? How fast can your motor system and your muscles don't learn, your motor system does, but how fast does your motor system really learn to do that action quickly and accurately? And that was the kind of memory that was tested here. And there were 2 groups. One group first trained on the task, then were awake for 12 hours for a full day. Then they were tested, and then they went to sleep for 12 hours. The other group, if you notice the AM and PM differences here, learned the task in the evening, immediately went to sleep, were tested in the morning, and then tested again in that evening. So the difference here, there's the same amount of same time differences between these training and test periods. But some are filled with sleep, some are filled with wake, and that allows us to really try to understand what role sleep plays in this kind of memory. So let's see what the results showed. I'm going to show you results for speed, for how fast they were. This is this slide. Next slide, I'm going to show you how accurate they were. So this is the group that first were trained in the morning. This is the blue bar on the left. Then they were tested in the evening. Then they went to sleep, and you can see this very nice and very strong jump in their speed. They were much faster when they woke up the next day. Is this just a matter of the delay, of the 12 hours that passed? No, it is not, because for the group that first trained on this in the evening and then went to sleep immediately and then were tested, you can see this rapid increase happening much, much sooner, and importantly, immediately after that period of sleep. Same goes for accuracy. So for the group that for both groups, you could see the number of errors going down immediately after this period of sleep. So this is good evidence that sleep not only improves our memory for facts, but also our motor learning. So we talked about which memories are enhanced. Now I'm going to talk about when memories are enhanced during sleep. So as many of you probably know, there are different stages of sleep. There's a stage of sleep where we are more likely to dream. This is the rapid eye movement or REM period of sleep. It usually happens in the second half of the night. That's why when we wake up in the first half of the night, we are less likely to have memories for dreams, whereas in the second half of the night, it is more likely. The first half of the night is what we might call deep sleep. And this is also referred to as slow wave sleep. And the reason is that if you look at the electroencephalogram, so the EEG, the electrodes we put on people's head to monitor their sleep, you see these very, very strong, very, very robust waves, which are called slow waves. So the first half of the night is more slow wavy, more deep sleep. And the second half of the night is more REM or dream sleep. And the question is, which of the two is more related to sleep consolidation? And that's the question that a study that was done in 1997 tried to address. In this study, again, they looked at memory that is more for facts, not motor memory. And the task was rather simple. They had a category, for example, animal, and they had a specific exemplar from that category, such as a dog. And people had to learn this relationship. They had to learn that when they are asked for that, when they see the word animal, the correct response is dog and not cat or mouse or something else. And they were later tested to see how their memory was for this. And importantly, going back to the different stages of sleep, this task was done again in two groups, just like the task we talked about before. One group was taught these associations just before this period of slow wave sleep, and then were tested immediately after it. Whereas the other group was taught this task before this period of REM sleep and tested immediately after that. With the idea being that we could, using this technique, we could see whether people get better during this REM period of sleep, whether the memory is consolidated during this period or during this period. And the results were quite striking and at the time very surprising. They showed that it is the first period of time, the deep sleep, that is relevant, that is most relevant for this memory for facts. So we are comparing the wake groups, so groups that were awake during the same period of time, learned the same task, but just did not sleep, versus the sleep group. And you can see this increase in memory and the percent of items recalled. And this is true for the deep sleep group. It's not true for the dream sleep group. And this is one of the first studies that really showed that it is deep sleep, it is slow wave sleep that is really essential for memory consolidation. This is mainly true for the memory for facts. It's more debated for other forms of memory, such as motor memory. But I'm gonna stick to the facts, stick to this sort of memory for this purpose. And then the last thing I want to talk to you about is, or not the last thing in this section is how memories are consolidated. So what really happens in the brain? And I'm not going to go too much into the anatomy because I'm not sure if I throw different terms at you that would be helpful to any of us. I would just say that during the day, when we acquire new memories, there are different areas of the brain and different cells in the brain or neurons that form interconnections. And these interconnections are memory specific. So for a memory to be formed, there has to be a certain set of connections that are formed, and that is the neural substrate of the memory that is formed. And then when you go to sleep, these same memory, I'll call them ensembles or assemblies that are related to that memory, they are activated again. They are activated again during sleep. They're activated in a more rapid way. We call this replay. So basically the same set of cells that is related to a certain memory is reactivated in the exact same way as in wake, except much, much more rapidly. So about 20 times as fast. This happens over and over again. And what this does is it establishes and cements these forms of memory that are in a part of the brain called the cortex, here signified by red. So they become independent assemblies that are in coded memory. And that is after that sleep, they are much more independent. They are much more able to act individually. And that is based on that sort of replay, or sort of, you can say that the brain is kind of training during sleep. So during sleep, there's some sort of repetitive training or rehearsal of what we learned during awake, and that makes our brain better at retrieving these memories and operating these memory traces. So that was sleep and memory consolidation. And now I'm going to talk just a bit about how we might be able to use this information to bias memory consolidation, so affect sleep consolidation in selective ways. And in order to do this, so this is, again, not a very new idea, but rather in about 100 years ago, or in 1931, there was this very influential book called Brave New World by Huxley. And in that book, which was sort of a dystopian novel, one of the ideas that are described for the future is that we will be able to learn stuff during sleep, and it's actually used for very ill purposes in this book. So we will be able to learn or be influenced during our sleep. And this idea has really intrigued and excited a lot of people, scientists and science fiction novelists over decades. And the question is, can we really do this? And I'm going to answer this over the next few slides. I'm going to say that already that the answer is yes, but we can't do anything, we can't do everything, and we'll talk about that in a second. In order to do this, we first have to find a way to monitor which stage of sleep a person is in while they sleep. And that's what we do in our lab. We do that using the electroencephalogram that I mentioned earlier, or EEG. You can see this in this video right here. We put caps on people's heads, and these caps have these tiny little electrodes that send signal through these colorful wires. And the person is asleep with the cap on, and in the computer, we can see these brain signals that basically reflect the electrical activity as recorded in the scalp. And that electric activity will let us know whether a person is in slow wave sleep, REM sleep, basically any form of sleep, any stage of sleep. And that will help us to know how we can direct the manipulation that we want to inflict to a specific brain state. So let's talk about, So let's talk about an experiment that was done in my lab and has been very influential with regard to biasing consolidation. And that is a study that was designed to selectively improve memory with targeted reactivation. So I'm gonna unpack this header and say that what we wanna do is we wanna do that replay that happens during the night, that rehearsal that happens. We wanna bias that. We wanna affect which of the memories will be reactivated during the night or rehearsed during the night, and which will not. And then we can influence some of the memories, but not all of them. And we can do this selectively. So we can choose which memories we want to enhance and which we don't care about enhancing as much. And here is the experiment, or the first experiment that is tested this kind of idea. We have people, so this is a spatial location task. We have people learn the locations of different items, such as an image of a cat or an image of a kettle. And while they learn the locations of the cat is on the bottom left, the kettle is on the upper right, we play them the sounds related to that image. This happens, of course, during wake. Participants are sitting in the lab and just participating in the study, hearing those meows and learning to place the cat in its correct position and the kettle in its correct position. And what's important is that we will decide that some of these we will later try to reactivate during sleep. Others we're not gonna reactivate at all. And this is the important comparison. So whereas before we compared awake people to sleeping people, now everybody is asleep, but some are being biased for a specific reactivation of a specific memory, whereas others are not. So while they sleep, specifically when they are in stage 3 of sleep, so in the deepest stage of sleep, we wait for them to get to that stage. This is during an afternoon nap. And then we play 25 of these 50 sounds. So we play the meow. We do not play the kettle whistle. And this is just examples. We basically play half of the sounds and we do not play the other half. We play them kind of softly. It does not wake people up. We still know that it is processed, but based on the EEG signals and the behavior later on, but it does not wake people up. We play it kind of in a soft way. And then we test them again. We ask them, okay, so where is that cat and where is this kettle? And the striking result is that whereas the uncued items get worse over sleep, and that again, it happens, and we saw that in the 1924 study before, memories get worse in general. So they get worse, the error goes up. For the cued ones, for the ones we play during sleep, we see a much smaller decline in memory. So just for these items, this is the same, these are in the same participants, different sounds, and we see this effect. And this has since been replicated for dozens of times, including in some of my own studies. So it seems a very robust phenomenon. People wake up, they don't remember sounds even being presented, but they are still better at these sounds just because when we played those during sleep, we somehow made those memories rehearse more than others. And this is for sounds, but it has also been shown for odors. So people can smell a certain smell during sleep, and if that smell was linked to certain memories, those memories will be enhanced. So we can definitely enhance memories that have already been established during wake, but can we also change memories during sleep for something that is brand new, that happens only during sleep? So this is the second study I want to show you, and I'm going to present so the question here really is, can we, so in the previous study, we learned something during wake, and then we hammered it in during sleep. In this study, it's different. We're only going to learn during sleep. We're not taking something that has been learned during wake and hammering it in. We're teaching something new during sleep. And the question is, can that be done? And this is a study from 2014 by an Israeli group from the Weizmann Institute for Science. And what they tried to do was they tried to help people quit smoking using sleep cues, not cues. And they did this in a very interesting way. They took smokers, they had them sleep in the lab, and they put on this sort of mask in which they could control the odors that they smell. And for some of these participants, for half of these participants, during sleep, when they were deep asleep, they had a cigarette scent that we all know so well. But immediately after that, they introduced a rotten fish smell, which we all probably dislike. And so they tied these two together. They made this sort of connection between cigarette smell and rotten fish smell. For the other group, for the other half of people, they just presented the rotten fish smell. They didn't link it with any of the cigarettes. And the question is, what happened to people's behavior when they woke up? Again, they woke up, they didn't remember smelling any of this, and they went about their lives, and they filled out a diary covering their smoking activity throughout the next week. This is kind of maybe a too detailed slide, but we'll try to unpack it together. So baseline is what happened the day before that nap. Before they slept, these two groups, this black and gray groups were the same. The black is the group that we're gonna tie that smoking with the fish for. the gray is the group that we're just going to present the fish smell without the cigarettes at all. So they were both pretty much the same before the study started. Then they went to sleep. And then over a course of a full week, you could see that, that the group for which we tied the cigarette smell with the rotten smell smoked less, not zero, but less, showing that there was some sort of thing that has changed for their perception. And this gradually, so follow me with the black lines, this gradually increased so that basically after a week, they were pretty much the same as the other group. But for the other group, nothing happened. Just presenting the fish smell during sleep really didn't do much. And so this is some form of a temporary effect, but this is just one night of sleep, and imagine that this can be extended to more nights and even to a protocol that could last for months. So I'm not an expert on smoking, and I'm not, the conclusions I want you to draw from this are not about smoking in particular. They are more about the fact that there can be some form of new learning happening during sleep. It's probably not, so we now know 6 years have passed and we know much more about this. And we are now pretty certain that, that this does not mean that we can teach you whole new stuff, whole new languages, or very complex, past complex messages during sleep. So those debunked cassettes that from the 70s and 80s that, you know, talk to you during your sleep to learn a new language or to make you stop smoking, those, as I mentioned, are debunked, and those don't work. That's not what sleep learning can do. But if we can, we are able to tie two relatively simple stimuli together, and that sort of teaching can happen during sleep and does not rely on your conscious perception, or at least waking perception. So that is that covers what I wanted to talk to you about sleep consolidation and whether we can affect it. And now, just because of the group that I'm talking to, I added a slide. This is not my field of expertise, but I thought that I might talk really briefly about sleep across a lifespan and in older adults, and some tips based on a book that I highly recommend that I'll discuss in a second. So what happens to sleep over the lifespan? So here we have on the x-axis age, starting from around age 5 and up to 85. And then on the y-axis, we have the number of hours of sleep, and it's layered into these different sorts of different stages of sleep. But if you look at the overall sleep, you can see, for example, that 5-year-olds sleep about 9.5 of every 24 hours. And probably pretty obvious to most of you, sleep declines over time, and it declines even further the older we are, especially if you account for this blue period of time, which is wake after sleep onset, that is falling asleep and laying in your bed, falling asleep, then waking up in the middle of the night and not being able to fall asleep again. And this unfortunately increases more and more as we age, and I'll talk about that a bit in the next slide. So that's one thing you can notice. The next is the amount of REM going down, the amount of stage 3, which is critical for memory, going down. So definitely sleep becomes more challenging, especially with respect to memory consolidation, which is mostly dependent on stage 3, on this deep sort of sleep. It becomes worse and worse over our lifespan. And even me at age 38 already passed my prime years for sleep efficiency. The question is what we can do about that. There's a whole school called sleep that is dedicated to sleep hygiene, or how to make your sleep most efficient. And as I mentioned, this is not my field of expertise, but I do know a bit about it, and I would like to share some of those insights that are especially tailored for this audience. I would like to add that a great book that is very recent, very updated, and I highly recommend is Why We Sleep by Matthew Walker. You might remember his name from a study that I showed you earlier about learning about the memory, motor memory. So Why We Sleep, it came out in 2017, I think, and it's a very good book. And a lot of these tips are based on some of the advice in that book. So what happens when we age? So there are multiple things that happen in the same time. First, there's changes in circadian rhythms. So whereas, as I mentioned, those circadian rhythms are those patterns that go over 24 hours that tell us when we should fall asleep. These become much earlier, which is one of the major reasons older adults wake up earlier or go to sleep earlier. Another thing that is surprising, maybe to mention in the sleep talk, is the bladder getting weaker. And that means we go to the bathroom more during the night and have more trouble falling asleep after that. So this is actually a major cause for sleep disturbances that might be surprising because it's not directly sleep related. And then there's a decrease in stage 3 sleep, which I talked about earlier. I want to debunk a myth about sleep in older age, which is that the older we are, the less sleep we need. That's probably not true. It is true that the older we are, the less sleep we get, but that's not because our body is trying to hint to us that we no longer need sleep. It's because we can't sustain sleep. But if any of us or any older adult would sleep more, it would benefit them more, both to their memory and their health in general. There's a lot of talk about health in general, not memory related, in the book, and I recommend taking a look at that. So what can we do to try and improve? So first thing is that we can try and reset our circadian clock or our internal clock in ways that benefit us. If we get bright light in the very early morning, if we go out at 6 a.m., that will align our body to wake up earlier the next day and the next day and the next day, and also go to sleep earlier. And that will cement that change in circadian rhythms. So this is not to say that you shouldn't go exercise in the morning, for example. You definitely should, but wear sunglasses. Surprisingly, sunglasses block out a lot of the light and make your body adapt less to that light and change less of the circadian rhythm. And maybe even more importantly, try to get as much bright light later in the day. So in the afternoon, if you go outside in the afternoon and get a lot of light, your body will be synced up with the change in daylight in general. The next thing is that if you have trouble falling or maintaining sleep, nap less. So a lot of times, because the circadian clock starts to get a bit earlier, we suddenly feel very, very tired around nap time because sleep pressure has always been there, but now the circadian clock comes earlier, and we feel that urge to go to sleep. And if we nap, we later might want to try to go to sleep, and we will lie in our bed and not be able to fall asleep because sleep pressure has dropped very significantly. In a related note, and this is something that every sleep physician will tell you, try not to stay in bed if you're not sleepy. So a lot of people will think that if they have a sleep problem, they should go to sleep earlier. In fact, most sleep doctors, I'm not a sleep MD, but most sleep doctors will tell you the opposite. Go to sleep when you're tired, and don't associate that staying in bed with that frustration, because that will keep you awake even more. So just go to sleep when you are tired, and don't spend time in sleep if you're not sleeping. And finally, I just want to say again, I'm not an MD, I'm a PhD, and this is not my specialty. So if you feel that you have sleep trouble, I would highly recommend consulting a board-certified doctor of sleep medicine. Finally, and this is again not directly related to sleep, but I think it is still of importance. Probably one of the major consequences of being an older adult and having trouble sleeping is actually not related to sleep, but rather to falling. So going out of your bed during the night to go to the bathroom, or because you are not sleepy, and that is a major cause of falling and of subsequent medical issues. And if you do fall, you might not have your phone handy, and you might not be able to call for help. So the last recommendation is not really sleep related, and it is to keep a phone near your bed with emergency contacts. Remove obstacles between you and your bathroom if you tend to go to the bathroom during the night, and use a night light to light the way so that you won't accidentally fall down during your walk. And with that, I'm going to end with wishing everyone great health and opening up to your questions. So I'm going to stop sharing my screen for this part.
Hello, I'd like to ask a question. Great presentation, thank you. And you really nailed it on that last slide about problems with sleep. Because I was always told, stay in bed, don't get up like in the middle of the night if you're awake. But it sounds like you're saying get up, do something, and you're sleepy again, go back to sleep.
Yeah, that is what I'm saying. It's mostly about when you fall asleep. So don't go to sleep when you're not sleepy. So don't go to sleep and hope that just the circadian rhythm will do its job. It probably won't. And a lot of the therapies for insomnia now, not just for older adults, but also for older adults, are mostly so there's medication, of course, but behavioral therapy tries to sever that link between the bed and that frustration of not falling asleep that actually enhances that frustration and prevents people from falling asleep. So if you would go, again, I'm not a physician, but a lot of physicians are now recommending increasing that sleep pressure and waiting until that reaches some climax in order to avoid that conditioning, that association between bedtime and frustration of not falling asleep.
And I just want to follow up regarding melatonin. Do you have any comments about that?
Yeah, so melatonin
versus regular.
Yeah, so again, not a physician. I'm going to say that every time I'm talking about anything that is related to medicine or treatments. Melatonin, what it does is it syncs up the circadian rhythm. So that has nothing to do with sleep pressure. It's not a sleep pill, at least in the sense that is commonly associated with sleep medication. What it does is it realigns your circadian rhythm. In most countries, it is a prescription medicine. In the US, I know that you can buy it anywhere, even though there's some studies that show that the dosage is not as high as what the bottles show. So I can't talk about the quality of store-bought melatonin. I would say that if you are traveling to another time zone, then definitely melatonin could be something that would help you. The effect, by the way, is much, much weaker than just hanging out outside and having light exposure. Light exposure is like 10 times as efficient as melatonin, but definitely doesn't hurt if you need the realignment of your circadian clock. If you're not jet lagged, then the issue might not be a circadian one. And in that case, I would not just use melatonin as without consulting with a physician that is board certified.
Thank you.
Yeah. Sure.
I'll ask a different question if no one else has a question. So you mentioned memory consolidation. I actually had read on that previously, and I was curious if you have any thoughts on PTSD and any techniques that were used to try to help people that suffer from that.
Yeah. So PTSD, or post-traumatic stress disorder, is that condition, that disorder in which people have a traumatic memory that I'm telling, of course, everyone else, that a traumatic incident that is invasive in their nightmares and during their waking hours, and really really disrupts their well-being. And there are many studies and many theories about what exactly sleep does to PTSD and how it might be beneficial. And there are different, I would say the jury is still out on this. Some would say that sleep prevention immediately after the trauma is the most beneficial thing, because then you won't have a consolidation of that negative memory. And in rodents, that's relatively true. In humans, again, the jury is still out if that's good. Right now, there's no approved sleep treatment for PTSD, but there's a lot of research going on in that field, trying to see what would be the best way to help these patients.
Okay, thanks.
Yeah, thanks, Eitan. That was a great presentation. I have a question too, actually. So, a, I had actually, I think I read some of the book that you talked about, Matthew Walker's book, Why Do We Sleep? I read it a while ago though, and I probably didn't sleep
I
enough
cannot hear you.
after I read it, so I can't really remember. But what I was going to ask is, do you know if there's any relationship between, people who have trouble falling asleep, they might need sleep medicine or whatever. Is there, would that affect the quality of sleep? And then would that in turn affect the type of memory or memory retention? Is there any type of relation that's known about that?
Between insomnia and is that the question?
Or
Or
medication, I guess.
I see. So
Yeah.
there are some medications that affect certain phases of sleep and certain phenomena that happen during sleep, and those have been linked to memory disruption. For example, there's something called sleep spindles, which we see in the EEG. Sorry, and those are disrupted by certain medications, and therefore memory is impacted as well. Most sleep medication, I'm not aware of their contribution or detrimental effect on memory. So insomnia, I mean, not sleeping enough is obviously important. I mean, it's obviously an important contributor to sleep-related issues, but I'm not aware of medication having any effect, either detrimental or improving memory in any specific way. So if someone wants to ask a question and not come online, you're welcome to send me a chat message and I will read the question if that works for some of you.
So I got a question in the chat. It says, how accurate are retrieved sleep memories?
I'm not sure what exactly is the. So what do you mean by retrieved sleep memories? I'm not asking you. I'm asking the person writing the question.
I guess what I was asking was when you're actually trying to create some sort of association during the test, the accuracy or the specificity of the memory, how broad is that association?
So that's a great question. I mean, if I answer correctly, the question is the memory that we're reactivating specific for if I'm playing that cat sound during sleep, am I reactivating just the cat memory or the cat's position, or am I reactivating some more generalized?
Yes.
Okay. That's nobody really knows, and that's actually the focus of my research right now. I have a study that that will get published soon, in which I have different images of cats. So just not just the one linked to a single meow, and I show that all 6 images of cats, all of them, the memory for them gets better with that cueing. So it seems to be sort of at least generalized in that category, and the question of how far that goes or how. So during wake we have these associations. We might think of something and it bring about something else, and that is linked to another thing. And during sleep we don't really know if that sort of those sort of ties are in play. We don't really know if thinking of one thing might or if reactivating one memory might reactivate an associate memory. That's an open question that I'm now actually trying to focus on in my own research. What is known is that one of the things that happens during sleep, and I didn't really talk about that a lot, is that memories are not only consolidated and strengthened, but also generalized. So during sleep, the gist of the memory seems to be extracted and linked to other memories. So it's not only that the memory becomes stronger, it actually becomes better embedded in that rich association of memories or of memories that make us who we are, and it becomes more gist-like and more generalized. So that is something that there's a lot of research about.
One other question, or two others actually. The sensory modalities that they were using were hear, sound, and odor. Have they ever tried touch without awakening the patient?
I'm not aware of a study that tried to do that. I was always curious, but I guess nobody really, it's kind of hard to be specific with touch. So with sounds, there's a whole richness of probably an infinite number of sounds that I will be able to use and they are distinct. With odors, it's probably an order of magnitudes less. There's different odors, but it's not as specific. With touch, it would have to be really, really general, I think. So you could say touch my right hand or left hand, I guess. And those are two forms of touch. Or you might be saying tickle versus stronger, even though stronger might wake a person up. So I'm guessing because of those reasons, that hasn't been really explored. The issue of specificity becomes a bit of a challenge there.
Okay. Great. It was a great talk. I just have one last question. Have you done any sequential, repetitive of the same association? And does that increase the duration of the, or the lack of degradation of the memory?
So multiple nights?
Yes.
Okay. Surprisingly little research on that. There's a whole branch of the targeted memory reactivation literature that is trying to look at TMR, or targeted memory reactivation, at home. And when we will be able to make that work at home, we can look at multiple nights. But bringing participants in for multiple nights has always been kind of a challenge, not unfeasible, but I guess enough of a challenge that there aren't really results on that. But I'm really curious to know because it's really, really, really unclear what the progression of memory is and sleep's contribution to memory over time. Is it only the first night that's important? Is it multiple nights, and does the contribution change over time? Nobody really knows because most of the studies have been single night studies, and this might be an important feature of sleep's impact on memory that hasn't been explored fully.
Great. Thanks. That's a great talk.
Yeah, thank you very much.
Sure, glad to be here.
Yeah, all right. So if there's no other questions, thank you, Eitan, for presenting. And just as a reminder, if you're willing to speak about your experience today, feel free to reach out to Tim or Michael Lee. I put their emails in the chat. So if you're interested in that, please email them. Otherwise, thank you so much, Eitan, and thank you all for joining.